All right, so I guess I'm gonna go to the iPad until my computer finally decides to hook up. I don't know what the deal is, why it's lagging. I mean, I started at 8:25 trying to get it to log in, and it just keeps still hanging up saying launch meeting. And so anyway, hopefully it'll connect up any minute and we'll go back to it. Just know that it'll probably make a really loud noise when it finally hooks up. So anyway, what we're gonna start out with today is, turn this around. What we'll start out with, I guess that doesn't work, is the chapter 8 test in the book on page 519. We're going to go through this as our review, so hopefully it will go a little better than it did yesterday. So that's going to be where we're starting. So go ahead and in your book, turn to page 519. No.
Are we doing the standardized test or just the test?
Hold on. Okay, sorry. Page 519, the chapter test is what we're going to go through right now as a review. So it's page 519.
All right. In case you wanted to, there's this little setting you can enable and like suppress the sound in the back.
Huh?
Like there's this setting you can put like on the audio and like suppresses all the sound in your back to where it can just hear you.
How does that happen? Where is that?
You know how like get to the settings on Zoom.
Uh-huh.
You're good at that, and then
Okay, I'll have to look for
then you're in
that.
audio settings, and it says press background noise like typing, dog barks, and then medium like. So that's why I do with my audio.
And I should have come to class today as a cat today. Have y'all seen that? Where the there is a thing where this past week, I think it was in Texas, a lawyer was meeting on a trial. So it's on the Zoom, it's 2 lawyers and a judge. And so he logs in and his profile's a cat. And so he can't figure out how to turn it off. And the judge is going, and the guy goes, well, I'm here. I'm not a cat. I'm ready to go. And it is one of the funniest things. If y'all have not seen that, y'all need to look for that. I about died because I was like, that would be so something I would do. I'd get stuck in a cat profile and I don't know how to get rid of it. So yeah, that would be me.
My dad showed that to me.
It cracked me up because I was like, I can totally empathize. That is me. Come on, computer. What is going on? I'm gonna try to. I just like being able to look at my computer and see things better than with the iPad. I like to be able to share my iPad. Let's see if now it's a little more. I mean, it has literally been running for 15 minutes now trying to log in. I'm gonna go out of it and try to do it again. Meetings. Let's join that meeting. And I don't know, sometimes our internet will be kind of wonky when it's kind of rainy, but I don't know. All right, while that's working, I'm gonna go ahead and share my screen so I can pull up the page that we're looking at. All right, so here we are at the chapter test. Let me erase, cancel. All right, so let's take a look at the first one. or the first three, we're just solving proportions, okay? Solving proportions, you're gonna cross multiply. And go ahead and just lay this down. All right, so let's go ahead and take a look at this one.
Where do we write the answers, in our notebook or on the test?
Well, I mean, it's the kind of thing where you're not having to, I mean, when anything that you're going to work out, you can just do it on paper, because you're not going to be turning this in. This is just something that we're using as a review for the test, and I'll be sending you the test today. So we're using this as kind of the chapter review, since yesterday was so messed up. And so since I was so off yesterday, I wanted to do a review today that where hopefully I don't mess it up as badly as I did yesterday. So this is just one more review before I send you guys the test today. So you can write on a piece of paper, but it does not have to be turned in. Okay, so we talked about how with proportions, I'm going to cross multiply. And so I know that I'm going to do 9 times x and 3 times 12. So 9x is equal to 36, divide by 9, divide by 9. So x equals 4, plain and simple. Okay. Oh, my computer says it's connecting. Hang on a minute. Oh. Okay. Oh, oh. Okay. Nope, now that's echoing. Hang on. Good grief. Okay, can y'all hear me through here? Okay, cool. Now I'm going to try to reconnect this one. So start. All right, I think I finally got it. Now I'm back. This. All righty. Let me put my participant box up just in case, because I don't see much for anybody to join in. Okay, so again, cross multiply. I always just draw my little arrows to help me remember. So I've got 15y is equal to 18 times 20. So 15 times y is going to be, what is that, 360? Divide by 15, divide by 15, and y equals 24. And then the last one, 110 times z, 11 times 10. So I have 110z equals 110. Divide by 110, and z equals 1. Okay, so basic cross multiplying, it does not matter if it's just two fractions, or if I have like a variable expression, if it was like, say this was z minus 5. Again, I still just cross multiply, but the main thing is if I cross multiply and I've got more than one term, I've got to be sure to distribute those terms, okay?
All right, so let's take a look at this one. Number 4 says complete the sentence. If F over 2 is equal to A over B, then F over A is equal to 2 over B. So remember how I talked about with proportions, we can set them up multiple ways. I probably said this 950,000 times this week, that it just means that you have to make sure that whatever corresponding information is together. All right. Now this one, remember that if X over 8 is equal to 3 over Y, remember my clue is right here, and I have 8 plus X in my numerator over X, then this one will be 3 plus Y over Y, okay? And as we go through any of these, be sure to let me know if you have any questions. All right, so this one now says find the length of EF. We've got our figure here, okay? So when I'm looking at my figure, and let's see, EF is gonna be right here. So remember how we talked about when I've got my parallel lines intersecting, that I can take, I know my sides or my segments are proportional, so this over this is going to be proportional to this over this, okay? I could have also done it where I have 2.8 over 1.4, 3.2 over 1.5, and over X. It doesn't really matter. So I'm just going to go ahead and say 2.8 corresponds to 3.2. So 1.4 corresponds to X. Okay, so again, I cross multiply. 2.8x is equal to 4.48. Divide by 2.8, divide by 2.8, x is equal to 1.6. So now I've been able to find that this segment is 1.6, okay? Now I need to keep going, and I need to find the length of FG. So now I'm trying to find this bigger length here. So again, I'm going to look at my corresponding sides. I'm going to look at what I know. We said this one was 1.6. Okay. So on this one, when I'm looking at FG, I can see that, and one of the things that I was going to tell you guys, that if it helps, instead of just plugging in the numbers, like in that situation, we looked at and we said, hey, DC, whoop, why is my DC over DE is equal to CB over EF. So if it helps you to write your segments first and then plug in the numbers, that's an option too. So like on this next one, let's look at finding, so I'm looking at CB over EF corresponds to BA over FG. So CB over EF is equal to BA over FG. So I can see that CB is 1.4, EF is 1.6, that's the one we just found. BA is 4.2, and then we're gonna let that one be X. So if it helps you to set it up as your proportional segments first and then plug in letters, sometimes that may help you with the organization of your numbers. Again, I'm going to cross multiply, and 1.4x is equal to 4.2 times 1.6, and that'll be 6.72. Divide by 1.4, divide by 1.4, and x is equal to 6.72. So now we have found FG, 6.72. Okay, so that is, Clara, we are on page 519, going over the chapter 8 test as a review for the test. Okay, so number 8 says, is quadrilateral FECB. So what I'm going to do is I'm going to, so FECB is going to be right here. Talking about this right here. So it's asking, is this quadrilateral similar to this quadrilateral, GFBA? Okay, So it's asking about similarity, and it says, if so, what is the scale factor? So do you remember when we talked about quadrilaterals, we said that sides will be proportional? And so when I look at that one, and I try to, so there's a couple of things that I can do. We also learned that their perimeters are going to be proportional to their sides. And so I can either go that route, or I can just go ahead and start looking at each of my sides and seeing if they are proportional. So in this situation, what I'm going to want to do is I'm going to look at my corresponding sides to see, do they make proportions, and are they the same? Oh, I guess Clara keeps dropping out. Let's see.
Hey, I'm trying to join in on my computer because my computer wasn't connecting to the internet. I'm on my phone right now.
I gotcha. Okay, see if that, see if, there we
I'm
go.
gonna turn off my phone, so.
Okay, that's fine.
I'm sorry. I'm taking.
Oh, you're fine. Hey, of anybody, I'm right there with you. Been having the same issues. Okay.
All right, I'm connecting to my computer. I'll be right in just a second.
Okay, sounds good. Thanks. All righty. So with this one, I can just look at my different sides, and so I can say, let's see. Let's start with. Okay, that was where I did perimeters. So when I look at, like, if I wanted to say 1.4 over 1.5 is equal to 4.2 over 2.25. I'm just looking to compare. I'm setting up my proportions with two sides from my first quadrilateral to two sides of the second. And when I cross multiply, 1.5 times 4.2 gives me 3.15. 2.5 times 1.4 gives me, nope, I did that wrong. Hold on, I wrote my numbers on the wrong side. Oh my goodness. There we go. Okay, so my 1.5 times 4.2 is 6.3, and then 2.5 times 1.4 is going to be 3.15. Since those are not equivalent, then I know that my two quadrilaterals are not similar, because my sides would have to be proportional. Again, I could have chosen to do two different sides. So just like we did a minute ago, I could have said 1.4 over 1.6 is equal to 4.2 over 6.72. And again, I can multiply, but I can see here that when I multiply 1.4 times 6.72, that is not going to give me the same product. So I can look at my sides to check proportionality, and if they are not proportional, then my quadrilaterals are not similar. Okay. If they were, then you would just give the scale factor. So basically you would set up a side over a side, give whatever the reduced fraction would be. Okay. Now in number 9, it says we need to prove that RSQ and RQT are similar triangles. So let's look at these two. Okay, so think about all the things that we've talked about with triangle similarity. We talked about how I can have angle, angle, side, angle, side, angle, side, angle, and side, side, side. Okay, so in this situation, so if I kind of go through all of these, I can tell that I'm not going to be able to go side, side, side because I don't have all three sides of all of them. Okay, so I'm going to work with what I've got. All right, so think about if I am using triangle RSQ. So that's going to be this triangle right here. And I've got to think about what information I know from this triangle. I can see that I have got a right angle here. And then I've got two angles here that I do not know the measures of. Okay. But notice that when I look at my bigger triangle that I'm having to compare it to, I'm having to compare to RQT. So that means now I am here. Okay, so when I look at this one, I can see again that I have a right angle. Okay, so both of them have right angles. So I know I've got an angle in common. But also notice, what else do those two triangles have in common? What angle do they both share? When I highlight both of those triangles, which angle do they both share?
90.
Well, they both have a 90-degree angle. So we've already said that. I have a 90-degree angle for both of them. But what else do they have in common?
RQT.
Not RQT. RQT is the one, but they both have angle R in common, right? So RQT and RSQ both have angle R in common. And remember, by the reflexive property, angle R is going to be congruent to angle R, right? So now they both have angle R. They both have a 90-degree angle. So in that situation, I have angle-angle similarity. So I'm able to prove that they are similar because they both have two, excuse me, congruent angles. Okay. So one of the things, like I said, that kind of helped me as far as being able to start with my smaller angle, shade it in, be able to look to see, okay, this one has a right angle. I know a measure of 15, but that's the only side I know. But then also saying, okay, now I've got angles R and Q. So then when I shaded my big one and I looked to see, okay, what does this have? It has a right angle, but then I can see that I have both angle R is shaded for both the pink and the green. So I see that those two are in common. So that kind of helped me to see it. Another thing, remember, because angle R, because R is my first part of both of those triangles, I can see that it's included in both of them. Now, because these are not in the exact same order, then they're not corresponding locations. So, but because R was first in naming both of them, that means they're both in corresponding locations. Therefore, they're going to be congruent. Okay. Now, the next thing says, what is the scale factor of RSQ to RQT? So think about this, okay? When we talk about the scale factor, that means that I can, when we look at our two, and one of the things that helps me also is I can say that RS over RQ. So I could compare those sides. I could look at SQ and QT. Okay, and then I know that QR and TR. So again, looking at the order of the letters helps me. If I'm not quite sure when I look at the figure and I go, ooh, what am I comparing to what? Just use the order of the letters and compare that way. So now I'm going to look, and so I can see that RS over RQ. Well, I'm going to erase over here so I can see a little better. So I know that RS corresponds with RQ, but I don't have a number there for RS. So I know that I cannot use those two. I cannot use that as my side to figure my scale factor. SQ to QT. So now I look and I've got SQ to QT. Again, I've got a number here, but I don't have anything here, so I cannot use that one. So now I'm going to look at my last one, and I can use QR over TR. And finally, I can see, hey, I've got two numbers here. So QR is 15 and TR is 25. So by just looking at the order of my letters in my triangle, I'm able to go ahead and set up my sides for congruent and for proportionality. And so finally, I found where I had two numbers. I've got 15 over 25. Those can be reduced, and that would be 3 over 5. So that is my scale factor. My scale factor is when I give the measure of two sides as a fraction and reduce it to simplest form. Okay. And then it says I need to find the length of QS. So I'm going to erase this real quick. So now in this situation, if I'm looking for the scale factor of QS, okay? So I can look back at my other proportions, and I can say, hey, I'm going to be finding, so I can put SQ over QT is equal to QR over TR. Well, SQ is what I'm trying to find, so I know that'll be X. QT is 20 equals 2. Now, you could either do, if we want to do QR over TR, you could do 15 over 25, or you can use your simplified scale factor. I'll go ahead and just use 15 over 25, just since those are our side measures. So I've said that SQ over QT is equal to QR over TR, okay? Now, the way that I know that those are corresponding is by looking at my order of my letters, okay? Sometimes it may be difficult to figure out which corresponds with what and what order, but by looking at the orders of the naming of the triangles, I can see how those work out. So here, I've got 25x is equal to 20 times 15 is going to be what, 300? And so 300 divided by 25 is 12. So QS is 12. Okay, so if you have trouble looking at the figure and being able to figure out how to set a proportion, you can always go back to the lettering order of how they have named the triangles to look and see proportionality. Again, first two over first two, next two over next two, and then last over first. Okay, so that's a way to always set up your proportionality. If it helps you just to list them out so you can see what corresponds with what, then I can plug in numbers and see what I have and what I'm able to solve for. Any questions so far? All righty, now we have our transversals and cut by some lines, and it says that we are trying to decide if we have enough information to conclude that we have parallel lines. Okay, so remember, if they are parallel, then my sides are going to be proportional. So we've got to look and use what they've given us to determine that. So here they've said LJ over JH. So I'm going to look at LJ over JH is equal to MK over KH. Okay. If so in this situation, we're not looking at measures. We're just saying, did they give me the right information to compare to determine that they would be parallel? Okay, so we're not having to solve for anything. We're just saying, if I knew those measures, could I compare? Am I comparing the right information? So in this situation, yes, I am. And that was our proportionality converse that said, if your sides are proportional, then the lines are parallel. Remember our proportionality theorem says, if they're parallel, the sides will be proportional. This one says, hey, my sides are proportional, so they're parallel. Now let's look at the next one. They're saying, what if we compared angle HJK, so HJK to HLM. Okay, HJK to HLM. So what I want you to think about here is, if I'm looking at this angle here and this angle here, if I was looking at these like with a transversal and everything, what do I know about the locations of those angles?
They're parallel.
I'm talking about angles. Angles can't be parallel. Lines are parallel, but we're trying to determine if the lines are parallel. think about when we learned about all the different angles that were on a transversal, and we had alternate interior, alternate exterior, corresponding, consecutive. Remember when we looked at all those different things, vertical angles? So what is the relationship between these two angles here? What is their location relationship? Okay, flip back to flip back to page 143 in your textbook. Page 143. Look at these angles that we're comparing and which one of these theorems line up.
Consecutive interior angles.
Okay, so remember, I'm comparing my parallel lines. I'm looking to see. So remember, interior would mean they would both have to be inside between my parallel lines, or both of these angles between the parallel lines. Nope.
No.
So it's not consecutive interior.
Consecutive exterior.
Okay, consecutive exterior means that they're both on the outside. That means that they would both be outside the parallel lines. That's what exterior and interior mean. Exterior means outside the parallel lines. Interior means inside the parallel lines. They're not both exterior. Let's look at this for a minute. If
It's
this is my
corresponding angles.
corresponding angles, if this is my transversal and they're both on the same side of the transversal, they're corresponding angles. Okay, so to be alternate interior, alternate exterior, that means they're on opposite sides of the transversal and they're either inside the parallel lines or outside the parallel lines. So I want y'all practicing with those. You've got to know the relationships of where these angle locations are. Okay, so postulate 15 says if two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So in this situation, they said, hey, these corresponding angles are congruent. Therefore, I can conclude that my lines are parallel. Okay, so in this one, yes, I can make that conclusion using the converse, the corresponding angles converse that says if two angles are congruent and they are corresponding, then I know my two lines are parallel. So one of the things that you might want to do is make sure when you look at a figure like this, that you think about, okay, these are my parallel lines. So are they outside, or are they inside? If this is my transversal, is my angle on both sides, on the same side or opposite sides? And that should help you to determine what is what. Excuse me, my voice is not wanting to work today. Okay, so now we have LH over JH as MH is to KH. Okay, so looking at those, I am setting them up in the correct portion, in the correct order for proportionality. So that would make, so I can see that that would be, and also in that situation, I have, in this one, I've got a side and a corresponding angle and a side for that one. Let me erase these two little angles. So I can see I've got my big angle, and actually let me change these colors so it'll stand out a little bit better. And then I'm doing this one right here. So again, they both have the same included angle, and now I've got these sides. So in this one, I've got side, angle, side. So yes, they're parallel lines. Okay, so again, like I said, it's a lot to really kind of learn and to understand, but the more you work with it, the more you practice it, the better it's going to be. All right, so number 16, it says the triangle RST is mapped onto triangle R prime S prime T prime by a dilation with RS is 24, ST is 12, RT is 20, and R prime S prime is 6. Find the scale factor and the side lengths. Okay, so let's think about this. I'm given my pre-image, and here is my image. Okay, so remember when I have a pre-image and an image, remember we've talked about how to find my scale factor. I'm going to have image over pre-image. Okay, so what did they say that RS prime or R prime S prime is equal to? It's equal to 6, right? So is that going to go in my numerator or my denominator? Is R prime S prime, does that go with my image or my pre-image? Do you remember which ones indicate the prime symbols? Image or pre-image?
Pre-image? No image.
Yeah. Gonna go with the image. When I have my primes, that's when it has changed to something, transformed to something. So by setting up my fraction here, I know that my image goes in the numerator, pre-image goes in the denominator. So my image number is 6. Now I've got to look at the corresponding information they told me, and they said that RS, my pre-image, was 24. So 24 goes in the denominator. So image over pre-image, or you can think about primes over not primes. However you want to remember that, that's how you're going to set up your fraction. So now I have 6 over 24, and I know that reduces to 1 over 4. So there's my scale factor. My scale factor is 1 over 4. So first of all, let's think about this. If I have my pre-image going to my image and my scale factor is 1/4, is this an enlargement or a reduction? Is my figure getting larger or smaller with my dilation?
Smaller.
It's getting smaller because remember we talked about how if my scale factor is less than 1, that means my image is smaller than my pre-image. If my scale factor is greater than 1, then it got bigger. It was an enlargement, okay? So paying attention to that scale factor, if it's less than 1, then it shrunk, okay? It was a reduction. So now we've got our scale factor, and now I've got to find what my pre-image and what my image numbers would be. So that means I'm going to set up ST or S prime T prime over ST is equal to my scale factor of 1 over 4. Okay, so I'm going to look at the information they gave me. They said that my pre-image ST was 12. So that means I can set up my image over pre-image is equal to 1 over 4. I'm using that scale factor to be able to solve. And I can cross multiply, and 4x equals 12. So x equals 3. So I can see that my S prime T prime equals 3. I'm going to do the same thing with R prime T prime over RT. That equals to my scale factor of 1 over 4. I've got to solve for R prime T prime, but they told me that RT was 20. So I plug that in here. So I have x over 20 is equal to 1 over 4. Cross multiply, and 4x equals 20. Divide by 4, so x is equal to 5. So that means R prime T prime is 5. So by using your scale factor, you're able to find out what your new numbers are, what your new segment lengths are of either your image or pre-image based on the information they have given you. Again, if it helps you to set it up with letters first, then you can make sure that you've got it in the right order. Remember, image is always your numerator, your prime is always your numerator, pre-image or letters without prime symbols are always your denominator when you're setting that up. Okay? All righty. Let's look at number 17. It says 2 sides of a triangle have lengths of 14 inches and 18 inches. The measure of the angle included by the sides is 45 degrees. 2 sides of a second triangle have lengths of 7 inches and 8 inches. The measure of the angle included by the sides is 45 degrees. Are the 2 triangles similar? So remember, if we're looking at side angle side, because they've given me sides, an included angle, and sides, okay? So that's what they're asking us to do, is to look at side angle side and see if these are going to be similar. So basically what I'm going to do is I'm going to say, okay, well, if my 2 sides are 14 over 18, then that's going to have to be equal to 7 over 8. Okay? So now I test them to see, and when I cross multiply, let's see, 14, grab my calculator real quick. 14 times 8 is equal to 112, and 18 times 7 is 126. So because these 2 numbers, when I cross multiply, they do not have the same numbers, then they are not similar. Okay. Likewise, I could have said, okay, fine, or I could have compared 14 over 7 and then 18 over 8. 14 over 7, 18 over 8. Looking at that, you can immediately tell that they are not going to be proportional, because 7 is half of 14, so that would reduce to 1/2. 8, I'm sorry, that would reduce to 2. 8 is not half of 18. So again, I can see that these are not equal to each other. So no matter how I set it up, which sides I compare, they are not similar. Any questions on that? All right, number 18, our favorite kind of problem, where we have a flashlight shining on a book. It is 9 inches tall and 6 inches wide. Makes a shadow on the wall that is 3 feet tall and 2 feet wide. Okay, so now one of the things I need to notice here is, what am I going to have to work with first? I've got 9 inches tall and 6 inches wide. But notice here I've got 3 feet tall and 2 feet wide. So I've got different units, don't I? So I need to make sure I'm dealing with the same units here. So if I'm comparing my height, let's go ahead with 9 inches tall. And I want to compare to the height of the shadow. They said it was 3 feet tall. How many inches are in a foot? 12. So 3 times 12 is going to be 36 inches tall, right? So my book, so I've got book over shadow. So over here, I need to go the width of the book over the width of the shadow. Okay. So when I look at this, again, I can look at 6 inches wide, now over 2 feet. So I've got to look at that, and 2 feet is going to be 24 inches. So now I'm comparing. Now with both of those, see, there's nothing I'm trying to solve for here. I've got measurements for both of them. The question asked me, what is the scale factor of book to shadow? So again, all I'm looking at are these 2 numbers here, and I'm looking for the scale factor. So to do that, 9 over 36 reduces to 1 over 4. Again, if I'm not sure, I can look at 6 over 24. That also reduces to 1 over 4. So my scale factor, whether I'm talking about the height or the width, it's 1 over 4 is my scale factor. And all I do is set up my 2 corresponding numbers, reduce the fraction. Okay. Any questions? Any questions? So real quick, I want to look back at a couple of things to make sure that you know exactly what to review for, because there is a good bit of information on this test. We're kind of covering a lot of things, but I want to kind of hit the high points real quick, and then we'll get ready to move on. And actually, we are 4 minutes over our break time. So let's go ahead and take a 5-minute break, and then we'll come back. We'll run through our theorems and things that we need to make sure we know, and then get started on chapter 9. So go ahead and take a break. All righty, we'll get ready to come back. What I want you to do is go ahead and flip back in chapter 8. Like I said, we're going to flip through a couple of things and then move on. All right, so start chapter 8 starts on page 457. On 457, we learned about ratios. We talked about how when our, if we have unlike units, we need to convert our units. Okay, so we have that first. Go ahead and look at page 459. 459 starts with our properties of proportionality. Okay, so the step 1 was the cross product property. That was where I can cross multiply to solve. Okay, so the cross product property is the first one. Then the reciprocal property also, that the reciprocals of my sides equal to are proportional. Okay, so so we have cross product property and then the reciprocal property. Then go ahead and turn over to page 465. And there we also have additional properties of proportions where it just shows that as long as, like if I have A over B is equal to C over D, then I can also compare A over C and then B over D, okay? Then, oh, sorry, I didn't change my screen. Okay, so that was where we said that, hey, I can also compare A to C and B to D. And then number 4, this was the one that we looked at in our review, where if I add the same number to the denominator, I can A over B equals C over D, then A plus B over B is equal to C plus D over D. Okay, so that was one of our examples that we had in the chapter 8 review a minute ago. All right, we're going to keep on moving and let's flip to, let's see what page I want to go to. Go to page 473, similar polygons. Remember we learned that similar polygons are going to have sides that are proportional and angles that are congruent. Okay, so remember, my angles are going to be congruent, but my sides are proportional. My sides are not congruent. Okay, so that's the main thing to remember there. Then turn it over to 475. This was the theorem that told us that if two polygons are similar, then not only are their sides going to be proportional, but their perimeters are also proportional. Okay, so not only can you look at the sides being proportional, but perimeters as well. Okay, now let's see, let's go to 8.4 on page 480 and 481. This is where we started looking at similar triangles. And with similar triangles, we learned that there are different ways to prove that triangles are similar. And the first was angle, angle. If I have two angles that are congruent, then my triangles are similar. Then we moved on over to, and also we talked in this chapter about how I can use my scale factors, I can use my angles, things like that. So when I have similar triangles, then I can look at my side proportionality. So again, same rules that we just talked about rules for proportional polygons. Since a triangle is a polygon, the same rules follow. So my sides are proportional, angles are congruent. And as long as I can prove that two angles are congruent, then my triangles are similar. I don't have to show that all three of the angles are congruent. Then we move on over to page 488. Again, we said sides are proportional. And if all three sides are proportional, then I can use side, side, side similarity. So if all three sides are proportional, then it's side, side, side. Remember, right now we're talking about proportionality. We are not talking about congruence when I'm talking about sides. My sides do not have to be the same measures to give side, side, side. My sides just have to be proportional. And then for side, angle, side, again, I'm dealing with two proportional sides and its included angle that is congruent. Angles are congruent, sides are proportional, side, angle, side. Okay. Then We will keep going to page 498. Okay, so 498 here, we talked about when we have parallel lines in a triangle. And if a line parallel to one side of the triangle intersects the other two sides, then it divides the two sides proportionally. So if I have parallel lines that intersect, my sides are proportional. The converse of that is if I have proportional sides, then my lines are parallel. Okay, so remember, my two parallels break it into proportional sides. Then on 499, we had our railroad track and bow and arrow. So basically it says that if I have with my railroad track, when I have my parallel lines, remember my parallel lines are going to be the ones that have the arrows on them, or I'm looking for my directions to tell me which ones are parallel. Okay, if to be able to assume that they're parallel, I have to be able to be given information to tell me that they're parallel. Okay, so also this was the one where in the example we had to look at our angle information. So if I had if I'm looking at an angle here, if I'm looking at an angle here and an angle here, remember I have to understand that those would be corresponding angles. Okay, if I was to be looking at an angle here and an angle here, okay, I can see that I've got alternates there. So thinking about, I'm not leaving all of those different things that I learned, all those theorems that I learned about angle locations. I'm not forgetting all that. I have to transfer it over to what I'm working with. So we talked about, though, when I have my parallel lines that intersect two transversals, I know that my transversals are proportionally intersected. So that way I can see that this side corresponds to this side and this one to this one. So that way I can set up proportionality. Okay. And also I can see that this is going to correspond to this. So I've got all that proportionality stuff going on here. Then with my bow and arrow one, I have my angle bisector. Remember, I can see that my angle is cut in half. So both sides are congruent. So that means that these two sides here, they're not congruent, so I won't do that. I can see that these two sides here are going to be proportional to my sides of my triangle. Okay, so my segment parts are proportional to the sides. All righty. So like I said, this was the one where we were talking about how I can look at my angle locations to help me determine whether my angles are congruent or not, based on, are they consecutive, are they alternate interior, alternate exterior, whatever. And then finally, 4.7 was our dilations. So looking at our enlargements or our reductions, the main thing to remember here is that when I'm looking at comparing my figures, I want to pay attention to where I've got to find my scale factor. I have got my image over pre-image. Okay, if you just remember image over pre-image, the prime figures over non-prime, that's going to help me figure out my scale factor, which we use to the letter K. We said that if my scale factor is less than 1, if it's between 0 and 1, it is a reduction. If my scale factor is greater than 1, it is an enlargement. Okay, so you need to remember that K equals C prime over CP, or you can remember K, the scale factor, is equal to the image over the pre-image. All righty. I feel like we have gone through that. If you have any questions before you start the test, be sure to let me know. I think you'll actually find the test to be fairly easy compared to what the work that we've done in the chapter. Okay. All right, we're going to shift gears now and move on to chapter 9. Chapter 9, right angles and trigonometry. Are y'all scared yet? You shouldn't be. It's going to be just fine. And I think that once you see this first section, you're going to be like, okay, this is a little bit of a breeze compared to what we've been doing. All right, so chapter 9, the first one we are starting out with, well, first of all, you can see what is this chapter about. Chapter 9 is about right triangles and a related branch of math called trigonometry. So basically, we are going to be focusing on right triangles right now. We know that that is going to be a triangle that has one right angle. Are you ready for the chapter? If you can classify as acute, right, or obtuse. If you know how to label the legs and the hypotenuse and the altitude of a triangle, vectors in a coordinate plane, and solving proportions. Okay, so those are the things that we know how to do already, so we're ready to move on. All right, so it says in lesson 8.4, you learned that two triangles are similar if their two corresponding angles are congruent. Okay, so if two corresponding angles are congruent, then they are similar. So for example, angle PQR is similar to angle STU. Recall that corresponding side lengths of similar triangles are in proportion. Okay, so remember that if I have two congruent angles, they are similar triangles, therefore their sides will be proportional. All right, so in theorem 9.1, it says the altitude is drawn to the hypotenuse of a right triangle. Then the two triangles formed are similar to the original triangle and to each other. So if I have a right triangle, okay, and I go ahead and draw an angle from the hypotenuse to that right angle, it's going to divide it into two similar triangles. Okay, so they've already told us that this theorem tells me I draw an altitude from the right angle to the hypotenuse, then I've got two right triangles that are similar to each other. Okay. So let's go ahead and take a look at this. If it said I needed a plan for looking at triangle ABC, and that is a right triangle, the altitude is CD, and drawn to the hypotenuse AB. I need to prove that triangle CBD is similar to ABC, that triangle ACD is similar to triangle ABC, and triangle CBD is similar to triangle ACD. Okay, so notice it says my plan for my proof. First, if we're wanting to prove this first one, whoop, that's not my highlighter. We're trying to prove this one here. So it says each triangle has a right angle and includes angle B. So again, if they both have a right triangle and they both include angle B, then I have angle-angle similarity, just like that example that we looked at on the chapter 8 review. Okay, we had one of these exactly like that, where we said, hey, they both have a right angle, they both have an included angle, therefore I can use angle-angle similarity. Okay, and it says you can use similar reasoning to show that ACD is similar to ABC. So again, you can see that ACD is congruent to ABC. So it says ACD is going to be this angle here, is congruent to angle B because they are complementary to DCB. Okay, so DCB. So I know that those are going to be complementary. What does complementary mean? What do they add together to equal? Add to equal 90 degrees, right? So if I see that when I look at these two here, if I'm given this one, then I know that when I add this one, it's going to equal 90 degrees because I've got that right angle. Likewise, when I am here, if I'm given 90 degrees and I know I have this angle here, I know that these two angles have to add together to make 90 degrees. So I have a 90-degree angle and I've got angles that are complementary. Okay. So again, you can use angle-angle postulate. Okay, so looking at, again, like I said, we're not going to focus too much on writing out proofs and stuff, but I still do want you to be able to look at these relationships and be able to figure out why are they similar. And you don't have to necessarily write it out, but I just want you to be able to understand and be able to tell me why. Okay, let's look at example 1. We have a roof. It says a roof has a cross section that is a right triangle. The diagram shows the approximate dimensions of this cross section. So it says identify the similar triangles here. So I'm trying to look and see my similar triangles. So it says you may find it helpful to sketch 3 similar triangles so that the corresponding angles and sides have the same orientation. So basically what they did is they said, hey, if I'm getting overwhelmed by looking at these things together, if I'm having trouble separating them out, then actually I can go ahead and do a sketch of those 3 separate triangles instead of trying to look at it as, hey, I've got this big triangle, and then I've got this triangle here, and then I've got this triangle here. Instead of trying to look at them all together, I can actually sketch them out separately. And I can take the measures that I know and plug them in. So now I can see that, hey, I've got this side for all of them. All right. I have a measure of this one, but I don't know the measures of these. Now on this one, now I can see that for my big triangle, I have all 3 measures. So I know that I can be using all of those sides as comparisons to find the missing sides of the other ones, okay? Again, I can set up proportionality. I'm just setting it up to say, hey, is this side proportional to this side? And when I compare that, is this side proportional to this one? So I'm able to use my proportionality here. So that's what it says. Look at YW over ZY equal to XY over XZ, okay? So I'm going to be comparing go away. Where am I? It went all the way to chapter 11. Good grief. How did I manage that? I don't even know how I even did that. Sorry, hang on. Technical difficulties. I'm almost back. There we go. Okay. So again, I'm looking at YW over ZY as XY over YW what did I do wrong there? Am I looking at the wrong thing? So I'm comparing, I guess, first of all, I need to make sure I'm looking at the right triangles. I'm using XYW, and comparing it to XZY, that one. Okay, so right now I'm using these 2 triangles because remember I said this one has all 3 of my measures, so I know I'm going to have to use that one when I'm setting up my proportionality. So I've got YW compared to ZY, so long side, and then I'm comparing XY to XZ, okay? So that way I'm able to solve for H. So when I set that up with my corresponding side lengths, I set it up, cross multiply, and I can solve for H. Now I see that H is approximately 2.7. Okay, so I was looking for that height. So in my diagram, I was looking for this one. I was looking for my height. So to be able to do that by breaking apart my 3 triangles, I'm able to see which 2 I need to compare because I'm looking at the big one that has all of the 3 measures. When I have a triangle that has all of the measures, I'm able to compare it to one that does not have all of the measures to set up a proportion and solve. Okay. Now let's go ahead and look at goal 2 on page 529. It says using a geometric mean to solve problems. Okay, so let's stop and think about geometric mean. Okay, we've looked at that previously. And remember, the geometric mean was where I would have A over X is equal to X over B. And remember, we said when I cross multiply, I'm going to have X squared is equal to A times B. So to solve for X, that means I've got the square root of AB. Okay, because when I have X squared, the way to solve for X is to take the square root of it. So using the geometric mean, I know I'm going to have to be working and using square roots because my denominator of the first and the numerator of the second are going to be the same. Okay, and when I have a number squared, to find that or to find a variable squared, to find that single variable, I'm going to have to take the square root. All right. So it says in right triangle ABC, the altitude CD has been drawn to the hypotenuse, forming two smaller right triangles that are similar to triangle ABC. From theorem 9.1, you know that triangle CBD is similar to triangle ACD, which is similar to triangle ABC. Okay, so again, they went ahead and broke them apart separately so you can compare and look. Okay, so now we can see that CD here, when they're broken apart, because here this one's upside down, or it's on its back. Okay, so what they've done is they've turned it to where they're all laying on the same thing. So it says, notice that CD is the longer leg of triangle CBD, and it's the shorter leg of triangle ACD. When you write a proportion comparing the leg lengths of triangle CBD and triangle ACD, you can see that CD is the geometric mean of BD and AD. Okay, so that is my geometric mean there. So what it says is I can set up the shorter leg of triangle CBD over the shorter leg of triangle ACD. So that's why I have BD over CD, because remember they both share the common CD leg. So I've said short leg over common leg equals common leg over short leg. Okay, or longer leg, I'm sorry. So short leg over short leg is equal to long leg over long leg. Okay, so so now I can see that I'm going to have a geometric mean. All right, it says sides CB and AC also appear in more than one triangle. Their side lengths are also geometric means shown by the proportions below. So I can see that I can take the hypotenuse of each of them and I can compare them. Hypotenuse over hypotenuse is going to be equal to shorter leg of one over shorter leg of the other. Again, my hypotenuse of one is the short leg of the other. So I've got geometric mean here. The other comparison is the hypotenuse of one over the hypotenuse of the other is equal to long leg over long leg. Again, my hypotenuse and my long leg are going to be the same. So I can use geometric mean. So it says, so geometric mean theorems. Theorem 9.2, in a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. The lengths of the altitude is the geometric mean of the lengths of the two segments. Okay, so they've gone ahead and told us that when I have this situation where a segment or where an altitude has been drawn from the hypotenuse, from the right angle to the hypotenuse, then I know that that segment is going to be, or that altitude will be, the geometric mean. So when I set it up, I can say that BD is to CD as CD is to AD. Okay, so I can compare those two sides. 9.3 says in a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. So the length of each leg of the right triangle is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse that is adjacent to the leg. So now this one is talking about that if I have AB, talking about that leg, over AC is equal to AC over AD. Okay, so again, long side, short side, short side. Okay, so we can set that up as well. So we're comparing those. Okay, so these are our two geometric mean theorems. The main thing to remember though is with both of these, I have got the same numbers or the same measures in the denominator of one and the numerator of the other. So when I multiply, I know that if I have to solve, I've got to find the square root. Okay. So the main thing here, this one is looking at the adjacent leg. This is looking at my segments. So let's see. Basically, in this one, I wrote myself a note that you may want to put over here. It kind of helps me instead of saying AB over CB, because whenever I work with it, I may actually see different letters. So one of the notes I've written myself here is going to be the total leg over leg. Let me write a little bit. Total leg over leg is equal to leg over segment adjacent to the leg. And so there will be a time that we look at this in a little bit. So that was just kind of a note that as I was going through, this is going to help you, because especially when I always have to look at my figures and relate back, okay, this one's AB, but in this figure it's EF. So by just saying, hey, I'm going to look at my total leg length. So when it said AB, I'm looking at this total leg over AC. Okay, I've got that total leg over AC. And then again, I'm going to have AC over the leg that is adjacent to the segment. Okay, so that's when I know that I'm looking at that one. Okay, so we'll practice with it. So let's go ahead and look at these examples. We're going to have to use the geometric mean to find the value of each variable. Okay, so remember, if I am given, remember this, we just talked about how that is going to be my geometric mean. When I see that altitude and I see a number by it, I know that I can take this number over that number is equal to the altitude over the other segment. So I've got segment over altitude is equal to altitude over segment. Okay, and it doesn't matter which one is first and which one's second. I could have 3 over x is equal to x over 6, or 6 over x is equal to x over 3. It does not matter as long as I have a segment in my numerator over the altitude in the denominator, altitude in the numerator, segment in the denominator. Okay, so I can see now that when I set this up, I've got 6 times 3 and x times x. So I have x squared is equal to 18. That means to solve for x, I need to take the square root of both sides. Remember that when I've got the square root of 18, you can either do like they did here and said, hey, I know that 18 is 9 times 2. And so therefore I know that 9 is a perfect square. If you don't remember perfect squares, then remember you can say, hey, I know that 2 will go into 18 9 times, and 9 is 3 times 3. When I'm dealing with square roots, I know that I have to have 2 of the same number underneath the radical for it to come out as a whole number, and whatever is not paired up stays under the radical, okay? The other thing is, and there's nothing consistent, there are going to be times in the book where we'll see that maybe they gave a simplified radical answer, or sometimes they give a decimal answer. You are totally fine to be using a calculator in geometry. So therefore, if you don't even want to work with simplifying radicals, you can use a calculator if you want to and just find, you know, what is the decimal equivalent. That's up to you. All right, now we're applying theorem 9.3. Remember, this is the one where I said I take the total base over my leg, and that is going to be equal to my leg over the segment adjacent to the leg. Okay, so let's look at what I'm talking about here. So in this situation, I have 5 plus 2. Okay, remember I said this is my total base. All right, so my total base here is 7 over the leg that I'm looking for, which is y. Okay, so total base over leg is equal to that same leg. I just repeat it in the numerator, compared to the segment that is adjacent to that leg. So the way that I know that I'm going to be dealing with 2 instead of 5 is because when I look at this leg right here, whatever this leg is in my denominator and numerator, the segment adjacent to that leg means what is the one that joins with the vertex of the leg that was the geometric mean. Okay, that's why I know it cannot, I'm not using the segment of 5. I'm going to use 2 because it is adjacent to the leg that I'm using. Okay, so that means that then it's over 2. So I have y squared is equal to 14. Therefore, since 14 will not simplify, my factors of 14 are 2 times 7. Both of those are prime, so they cannot be simplified. So you could either write it as the square root of 14, or if you wanted to do the decimal equivalent, you're more than welcome to. Okay. If you decide to use decimal equivalents, you can always just round to your nearest tenth. Okay. All right, so we have a monorail track, and it says to estimate the height of a monorail track, your friend holds a cardboard square at eye level. And I know that everybody's running around with a cardboard square to be able to hold it at eye level to make a triangle out of a monorail track, but you never know. Your friend lines up the top edge of the square with the track and the bottom edge with the ground. You measure the distance from ground to your friend's eye and the distance from your friend to the track. All right, in the diagram, XY is equal to, so when I look at XY, and I'm looking at this segment here, it says it is equal to the height, H, minus 5.7, because I took the total height and then I have to subtract my known. Okay, so remember, I'm going to set that up, and so I have the height minus 5.75, so that's what this segment is here. Okay, and it says, so now we can write our proportion using theorem 9.2, where I'm going to have my segment over the altitude is equal to altitude over segment. So let's see, let me get a different color real quick and we'll highlight what we're looking at. So I've got XY over WY is equal to WY over ZY. Okay, so remember, we looked at that and said, okay, so that means this is going to be H minus 5.75, and this one is 5.75. So therefore, I can have H minus 5.75 over 16 is equal to 16 over 5.75. segment over altitude equals altitude over segment. And again, if I flip-flopped and I have 5.75 in my numerator of one and h minus 5.75 in the denominator of the other, that is okay. It's going to end up being the same thing. What does have to be consistent is my altitudes has to be the denominator of one, numerator of the second. So I'm going to have 5.75 times h minus 5.75 is equal to 16 squared. Okay, so that's what they've set up over here. So we can see that 5.75 times h is 5.75h. 5.75 times 5.75 is 33.0625. So I'm subtracting 16 squared is 256. I set it up, divide by 5.75, divide by 5.75, and I find that h is approximately 50. Okay. So the height of the track is about 50 feet. So let's go ahead and look at our guided practice here. In exercise 1 through 3, use the diagram at the right. In the diagram, KL, this right here is what? What is that called? What is it when we are using the altitude? What do we, the altitude is equal to the what? The geometric mean. And remember, in a previous chapter, we learned about geometric means. So we've got to use that content that we learned previously. We're applying it to this section with right triangles. So remember, my altitude goes from a right angle to the hypotenuse. When it goes from the right angle to the hypotenuse, I have two similar triangles. Okay. So I can use that altitude as the geometric mean. The altitude is the geometric mean. Go ahead and memorize that. All right, so it says complete the following statement. Triangle JKL, so JKL is similar to triangle. Okay, so think about JK.
MLK.
Okay, so let's think about our letters and how we're going to start these. So remember, when I put my order, I have to have corresponding angles, right?
KML.
So KML, good. So KML. So I've got JKL is similar to triangle KML, which is also similar to which triangle?
JKM.
Close.
Or JMK.
JMK, good. JMK. So pay close attention to the lettering of, to the order of the letters. Look at your correspondings, okay? All right. So it says in exercises 4 through 9, use the diagram above and complete the proportion. So all I'm going to be doing is comparing and looking to see what did they tell me first. So what is the corresponding side? So I have KM to KL as what is to JK? What is going to be in that numerator?
JL.
I'm sorry?
JL.
Not JL. Remember, I'm dealing with geometric mean, so that's my repeating. So if KL is in the denominator, if KL's in the denominator of the first one, it's in the numerator of the second one. Okay. Look at number 5. JM over what is equal to JK over JL? If this is in the numerator, what do I know needs to be in the denominator? Remember, these two need to be the same. Okay. Let's look at, let's see, when I'm comparing the next one, let's look at what we're comparing. Again, I can see that they already have LK as my geometric mean or as my altitude. So I need to compare LM. So if this is my altitude and I have LM, what is going to be my missing segment? What is the other part of that segment? It's going to be JL right here. Remember, segment, altitude over altitude and segment. Okay, so that's going to be JL. Let's look at the next one. Let's look and see what they're comparing. They said that they want us to look at JM. So that's my total side over something is equal to KM over LM. Okay, so remember what theorem 9.3 said. So in this one, JM, that's my total base, right? So if I have total base over something is equal to KM, which is a leg, over the segment adjacent to the leg. So what needs to be repeating there? Okay, remember how I said total base over leg equals leg over segment adjacent to the leg. So in this situation, I can see that JM, that's my total base. Okay, and my total base, then the denominator is going to be my leg. And that's going to be equal to what? It's going to be the leg repeating that KM. Okay, remember total base over leg is equal to leg over segment adjacent to it. They told me that I've got the segment adjacent to it by saying, hey, I've got LM, which is right here. So I have total base over leg is equal to total base over adjacent segment. So that's going to be KM. I'm repeating. Okay, so in this situation, my denominator and numerator are actually the legs that are the geometric means, not the altitude. So that's why you've got to pay attention to, am I talking about theorem 9.2, or am I talking where my altitude is the geometric mean, or am I talking about theorem 9.3 where one of my legs is the mean? Okay, so you need to study those and memorize those. It would help you if you write it on a note card and have it out beside you while you're working to help you figure out, okay, am I talking about this theorem? Then that means I'm setting it up this way. Am I talking about this one? Then I need to set it up comparing the legs. Let's look at the next one. LK over LM is equal to JK over what? Okay, so notice I've got my long side over the short side of my first one. LK over LM. I've got my long leg over my short leg. So now what am I going to be comparing with the next one?
So
look at LK. I've got long leg over short leg. Whoop. So I've got the long leg over the short leg of the first one. Long leg, short leg. Are y'all good with that? LK over LM. I've got long over short. Now it says I've got JK which is the long leg of my whole big triangle. So if LK is the long leg of my big triangle, what is my short leg?
KM.
Uh-huh. MK or KM. Okay. And I would go ahead and call it MK because just to be in corresponding order. So I'm going to have MK. So we did long over short equals long over short. So again, you've just got to look and see what is the order of the first fraction or the first ratio in the proportion. Long over short is equal to long over short. Okay, now let's look at the last one. We got to get ready and go. I've got something over JK. So I've got long leg over MK, which is long leg over MJ, which is that one. Okay, so number 9 is going to be LK, this one right here. Okay, so what we'll do is we will pick back up with this guided practice. You will not have any homework on chapter 9 yet. Okay, but I will be sending your chapter 8 test. I will have some things to make sure for you to look back at to review before you take your chapter 8 test. Okay, I hope you guys have a fantastic break next week. So your test will be due when we meet back in class the Monday after the break. Okay, chapter 8 work, chapter 8 notes, chapter 8 test due the Monday we return. Okay, I hope everybody has a wonderful break. Be sure to let me know if we need to Zoom over break. I'm more than happy to. Y'all have a good week.
Bye, Miss Jennifer. Thank you.
Bye-bye, guys.
Bye. Thank you.
Bye-bye.